You've seen sunlight flood your room, you've watched the sky turn gold at dusk. But step into space and it's pitch black. The sun is still shining, so why does Earth glow and space stays dark? Today, we unravel one of the most misunderstood truths in physics. And once you see it, you'll never look at light the same way again. What is light, really? Light. It's all around us, yet its true nature remains elusive to many. At its core, light is a form of electromagnetic radiation, but what does that really mean? Imagine tiny packets of energy called photons zipping through space at incredible speeds. These photons have different wavelengths, and only a small portion of them are visible to the human eye. The Sentinel mission, a groundbreaking space observation project, has shown us that light exhibits a fascinating duality. It behaves as both a particle and a wave, a concept that challenged physicists for centuries. This dual nature is key to understanding why light behaves so differently on Earth compared to space, why Earth is bright. Now, let's turn our attention to our home planet. Why is Earth so bright when viewed from space? The answer lies in our atmosphere. As sunlight enters Earth's atmosphere, it encounters countless particles, molecules of nitrogen, oxygen, and other gases. These particles scatter the incoming light in all directions, creating a diffuse glow that bathes our planet in brightness. This phenomenon, known as Rayleigh scattering, is also responsible for our blue skies. Shorter wavelengths of light, like blue, scatter more easily than longer wavelengths. As noted by the popular science channel Bright Side, our atmosphere acts like a giant diffuser, spreading sunlight across the sky and giving Earth its characteristic glow from space. Why space is dark? But what about the vast emptiness beyond our atmosphere? Why does space appear so dark, even in broad daylight? The answer is deceptively simple. There's nothing there to scatter the light. In the vacuum of space, light travels in perfectly straight lines until it encounters an object. Without an atmosphere or other particles to interact with, light simply passes through the darkness, invisible to our eyes. As one Reddit user eloquently explained in an Eli 5 Explain Like I'm 5 thread, light only shows up when it hits particles or surfaces. In space, there are vast stretches where light encounters nothing at all, leaving us with the impression of infinite blackness, the role of reflection. This brings us to a crucial point. We only see light when it reflects off something and reaches our eyes. Think of a flashlight beam on a clear night. You can't see the beam itself, only the spot where it lands. But add some fog or dust to the air, and suddenly the beam becomes visible as light scatters off the particles. The Sentinel mission's observations have reinforced this concept. When we look at Earth from space, we're seeing sunlight that has been reflected and scattered by our planet's surface and atmosphere. Without these reflective surfaces, the light would remain invisible to us, the moon, stars, and shadows. Let's consider the moon and stars. Why can we see the moon shining brightly against the black backdrop of space? It's because the moon's surface reflects sunlight directly back to our eyes. The space around it remains dark because there's nothing there to reflect or scatter light. This phenomenon leads us to a fascinating puzzle known as Olber's paradox. If the universe is infinite and filled with stars, why isn't the night sky blindingly bright? Part of the answer lies in cosmic dust and the vast distances between stars. As Brightside explains, interstellar gases and dust obscure many distant stars from our view, contributing to the darkness of space, light in motion. Understanding how light travels through a vacuum is crucial to grasping why space appears dark. In the absence of air or other media, light moves in perfectly straight lines at its maximum speed. This is why astronauts can see stars clearly, but not the beams of light between them and the stars. A user on Reddit's Eli 5 forum provided an insightful analogy. Imagine photons as tiny bullets. In space, these bullets fly in straight lines until they hit something. We only see them when they bounce off a surface and into our eyes. Without surfaces or particles to reflect off, the photons remain invisible to us, even though they're constantly streaming through space. What it means for us. This understanding of light has profound implications for how we perceive our world. Light is everywhere surrounding us, passing through us, but it only becomes visible when it interacts with matter. In a sense, our perception of light is a dance between energy and substance, between the visible and the invisible. This realization invites us to reflect on the nature of perception itself. How much of what we consider reality is shaped by the limitations of our senses? Just as we can't see the light traveling through space, what other truths might be hidden from us, waiting to be revealed through scientific inquiry and technological advancement? The study of light and its behavior in different environments reminds us of the importance of context in understanding natural phenomena. What appears true in one setting may be entirely different in another. This principle extends beyond physics, encouraging us to consider how our own perspectives and environments shape our understanding of the world. As we conclude our journey through the illuminating world of light, let's pause to appreciate the profound simplicity of this cosmic truth. Light is everywhere but only visible when it touches something. Just like truth itself, it surrounds us constantly, yet becomes apparent only through interaction and reflection. The next time you gaze up at the night sky, remember the invisible rivers of light flowing through the darkness. Though we can't see them directly, their presence shapes our universe in ways we're only beginning to understand. In the end, it's not just about what we can see, but about recognizing the unseen forces that connect us all across the vast expanse of space and time.